The last time we reach right here, so we look at how you represent a vector, where you use the line, the length of the line represent the magnitude, the angle where you draw the line to the horizontal or the vertical, it represents the angle of the vector. You can give the vector a name with two uppercase letters at the ends of the vector of the line, and you draw an arrow above the two letters, or you can give it just one letter, a letter in bold. But if you write it, I can write it in bold different from the other letters that you write, then you just use a little line below it, and that represents the vector. Alright? Now, we want to look at horizontal and vertical component, and by the way, let me just tick these with this already, this and this. Alright, H and V component is really horizontal and vertical components of a vector. Suppose you have this vector. Alright? Now, the thing is, you have 7, at the same 7 Newton. 7 newtons. Alright? 30 degrees to the horizontal. Now the thing is, you want what they call the horizontal component and the vertical component. How are you going to deal with that? Right? That is the thing. Now, when you talk about the horizontal component and the vertical component, what are you going to do? You're going to start at the end of the vector and draw a horizontal line. You start at the other end of the vector and draw a vertical line, so that the horizontal line and the vertical line meet at 90 degrees. Now, you see that length of the horizontal line, that is what you call the horizontal component. And the length of the vertical line is what you call the vertical component. And you can actually calculate them. Alright? So suppose you consider this vector. You say 30 degrees, 7 newtons. The horizontal component would have been what? Alright. Well, try a thing. You remember your sine theta equal opposite over hypotenuse. Your cosine theta equal adjacent over hypotenuse. And your tangent theta equal opposite over adjacent. You should remember those. Right? Suppose you consider, say, you have cos 30 equal adjacent. The adjacent will have what? Now h over the hypotenuse at 7. So the horizontal component h would have been 7 times cos 30. Now, sine 30 equal the opposite. That would have been v. Remember now, you know, opposite. The 30 upon the left hand side of the triangle, and the v upon the right hand side. Left and right are opposite, so are opposite sides, right? Sine 30 equal opposite, which are v over the hypotenuse 7. So v equal 7 times sine 30. Alright. So generally, suppose you never know say 30 and you never know say 7. Then this 7 would be the magnitude of the vector. So here now, you consider this 7, this would be the magnitude of the vector, right? And this angle would that be, well, just the angle of the vector. Now, suppose you call this vector A, B, then the magnitude would that be AB, but you need to do something to AB to show that it's magnitude. What you do is draw two vertical lines. You remember, what they call it again? Modulus. So the same thing you do. This is the magnitude of the vector. Alright? And then the angle. You know, so Greek letters, they use Greek letters to represent a lot of things in maths and science. In this case, in this case, the angle generally represented by something like alpha or theta or something like that. Call it theta, Greek letter theta. Alright? So, what you can say now is the horizontal component. You represent it with AB cos theta. And the vertical component equal, it should have be AB sine theta. So you remember those. Horizontal and vertical component. Remember, I said the horizontal component, if you have the angle here, so is usually the case, would have be the adjacent, cos adjacent over hypotenuse. And the vertical component, sine, opposite over hypotenuse. The hypotenuse is always the magnitude of the vector. Alright? So you see that? Alright, so those are H and V component. Now sometimes they use I and J. Just like in a complex numbers, use I and J to represent the horizontal and vertical component. So if we draw the vector again, right? And we say we have the horizontal component and the vertical component. They represent the horizontal component using I, lowercase I. Remember, it's not uppercase I, that's wrong. It's lowercase I and J, uppercase J. Right? So, just like up here, you have the vector, right? H and V, you have I and J. I would that be I equal AB cos theta and J equal AB. Vertical line AB sine theta. Alright, we'll see what happens in the next video as we continue.